Hello, Frank Conjal with Zeiss with another video walkthrough for Zeiss CALYPSO Programming Level 1, Exercise 8. Exercise 8 begins on page 121 of the training manual. This exercise will utilize a few navigational concepts in CALYPSO. The first step is to fixture the workpiece as shown with the navigation block on top. Shown here is the CAD cube with the navigation part on top. We'll be using the star probe and no CAD model for this exercise. Looking at the print, there are three objectives: report the diameter, report a Cartesian distance, and report a parallelism. Let's begin. We'll open a new measurement plan in CALYPSO. Just as to not forget, we'll turn on our filters and outliers first. And we'll go ahead and open our base alignment. Looking forward, it's easiest to probe the points in a logical order to make polyline modification easiest that it can be. This will be sufficient for the top plane. Note that the down probe was active when I created this. That will fill in my rotation in space and my Z origin. Perhaps the large circle in the middle could be an XY origin. To make this as easy as possible, I'll take 3 points on one side of the block. Now we need a planar rotation. Perhaps we could choose the right side plane. For this, we'll need to activate our left tip and probe in a logical order. This base alignment is sufficient. We can now do our clearance planes. Note that it's easiest to choose your down probe, and we'll create our box. Encompass the whole part with your down probe active. Do not worry about the left and right, back and front tips. Only focus on the down probe. View your clearance plane from above to ensure that everything is inside the box. and hit OK. If you'd like to take CALYPSO's suggestions for clearance planes, you can hit yes. Double check that these clearance planes are correct. In the manual, the first objective is the 30mm diameter. As far as strategy modification, we'll open up this circle. We'll go to strategy, and we can copy and paste this circle path. And we'll add 180 to this number. We'll call it an even 180. Then we need to insert a clearance data in between the two circle paths. Finally, we need to ensure that the retract distance is small enough to not come down on the top of the navigation part. We'll try 0.1 millimeters. Double check that the clearance data for the second one is also 0.1. We can now record a characteristic by checking the diameter, clean up the nominal, tolerances are correct. The next challenge is to modify the top plane so that CALYPSO can jump over the navigation block. If you strategically put your points out, all you need to do is change this polyline into points. Choose the first set of points, create a polyline out of that, watch your speed and step width, and choose the final points to create a polyline out of that, watch your speed and step width, and finally, in between the two polylines, we can add a clearance data to jump over the block. The final challenge with this print, which includes the distance and the parallelism, is to measure the underside plane. We'll do this by probing with all 4 styli, starting with our back tip. With the back tip, I'll take 2 points on the underside plane. Without hitting OK here, I'll activate my left tip. Take 2 points on the underside plane on the right. Without hitting OK, I'll activate my front tip and take 2 points on the back. Without hitting OK, I'll finally activate the right tip and take 2 points on the left. Here, we will hit OK to choose the feature. If you click yes, CALYPSO will automatically put clearance data in between each point. If you click no, you can do this yourself. If I open plane 3, choose the strategy, I can go through and create each pair of points into a polyline. Watch your speed and step width. I can then go through and create each pair of points into a polyline. Watch your speed and step width. Finally, we need a clearance data in between every polyline. Double check the first clearance data applies to the first polyline that we created, coming from the negative y. The second clearance data applies to the second polyline. This should be coming from the plus x. The third clearance data applies to the third polyline. This should be coming from the plus y. And finally, the last clearance data applies to our last polyline, which should be coming from the negative x. If you did this yourself, click No to this question to not allow CALYPSO to modify your strategy. Finally, we can add a parallelism of the bottom plane to the top with a tolerance of 0.1. And we can add a size, distance, Cartesian distance of the top to the bottom. This nominal should be 63 plus or minus 0.15. You're now ready to run this program. Run your program with the program name, slow speed, turn your speed knob down all the way, and begin. Once your program runs through, please send the PDF report to your instructor.